Good morning, everyone. This webinar addresses a crucial topic, electrical fire in hospitals. This webinar is an initiative of NFE, National Federation of Engineers for Electrical Safety, and supported by FSIS. The motto of both associations is to make the nation electrically safe. Keynote speaker is Mr. Sri M.V. Deshmukh. He is the chairman of Fire Safe India Foundation. He had an illustrious career as a fire professional for more than 4 decades. He is a gold medalist of the National Fire Academy and has been awarded fellow of IFE UK. He has a passion for continuous learning and education and has acquired master's degree in business administration, in law and information technology, as well as diploma in industrial safety. He retired as a fire advisor and director government of Maharashtra, managing and strategizing fire prevention and fire safety. He, along with his team, was instrumental to drive major reforms in Maharashtra's fire and life safety, legislative reforms, academic reforms, capacity building programs, mass education and awareness program. In his long career, he has handled additional responsibilities like HR, security, and IT departments of MIDC, as also being CFO MIDC for more than 15 years. He helped launch ERP in MIDC. He has been instrumental in driving mission Fire Safe Maharashtra. Our subject speaker and president is Mr. Sri Gopakumar. Yes, Gopakumar is an electrical engineer. He is a founder and promoter of Cape Electric Private Limited, Cape Electric Power Production Private Limited, OVO Betterman India Private Limited, JV of Cape and OVO Germany, LP Consultants International Private Limited. He is a member of the technical committees of BIS, ETD 20, NEC 23, 2023, IS 732, IS 3043, IS IEC 62305, ETD 30 Surge Arresters, ETD 50 LVDC National Building Code 2016 Electrical Committee. And also he is a member of IEC TC 64 Electrical Installations and Shock Protection, MT3, MT12, MT40, MT41, PT 603648 WG43, TC81 Lightning Protection of Structures, AHG 90, MT3, MT14, MT21, WG80. S337 ASPDs for lightning protection of electronics, WG03 and WG05. Another subject speaker is Mr. Atanu Chanda, is an engineering graduate with MBA. He having nearly 27 years of experience in working in medical device and further related test equipment industry. Has vast experience in medical device industry, previously being part of the leading medical device organization for 17 years and worked closely with hospitals, biomeds, etc. Leading Fluke Biomedical India operations since 2013 when Fluke established its own team for biomedical and radiation safety products. Being in the country manager for Fluke Health Solutions, expanding the business in the neighboring countries too. He has seen the biomedical test equipment market from a very nascent stage to the present stage wherein test equipment is being part of the biomedical toolkits. Over to Sri M.V. Deshmukh for the keynote remarks.
Thank you, Lakshmi, for a brief introduction and inviting me here to discuss about the fires in the hospitals. I'm extremely grateful to all the participants, those who have shown keen interest in the subject. This is rather the burning subject has become of the day or this last few years, especially after COVID, it has come too much in a highlight. And prior to that, the fire of the Ambri Hospital, Calcutta was an eye-opener for all of us. In spite of the experience, we do not see the much required, the much improvement in on the subject matter. And that pains really me. And same must be with all of you too. As to set the path of the today's discussion, I would say there are many things related to the fire safety or the fire in the hospitals. And I shall just highlight a few points here. One of the point which all of us, we know that the patients, those who come to the hospital to save their life, and they have to suffer either the serious burn injuries or even they have to suffer the loss of life. Casualties are occurring. They are not due to the inadequate medical aid or the lack of care by the doctors or the hospital. In this particular case, the people, those who come to save the life, and they are succumb to the death or the serious injuries due to the fire. Many hospitals in Maharashtra, at least, and some part of Gujarat, when I visited aftermath of the hospital, uh, there are some points which I noted there on a very operational angle and a practical way. One is the patients are informed patients, and the occupancy like any other hospital. I mean, the occupancies like maybe the residential occupancies or the commercial buildings or industrial. The occupancies are the informed patients, ambulatory patients, and many of them, they are in the life support systems in the ICUs or CCUs. Now, such patients to, mobilize to the safer place or the place of ultimate safety is a Herculean task, because they are on a life support system. You cannot pick up them like any other occupant or any other human being, and you cannot carry them on the open ground down the hospital. But you have seen in one of the hospitals in Gujarat, the patients were brought on the street with all the support systems even. So this situation we always have been recommending and trying to bring into the National Building Code, that there should be an arrangement for the horizontal evacuation of the patients. What I mean is, most of you must be knowing, but what I mean is the evacuation, horizontal evacuation is from the same floor. There should be a proper compartment, and from at least the compartment A to compartment B, we should be able to accommodate the patient. Obviously, for such kind of evacuation, the staff of the hospital has to be thoroughly trained, and there should be a proper, the mock practice, at least the dry practice. I'm not telling them to move the patients for the practice purpose, but that has to be seriously taken up. And for this purpose, this kind of a compartmentation, you have to have the independent HVAC system. You have to have the independent smoke management system, so that the fire in the one compartment or the one wing of the hospital will not spread to the other wing of the hospital. Second thing is the use of the lifts for moving other patients with the help of stretchers, and certain extent the ramps. I have seen in some states, they have recommended the ramps throughout the hospital. I don't know how practical it is. As an operational fire professional, I really doubt whether that can be done in case of an emergency. But okay, people are going in a panic, and with good intentions, they are doing it. But while applying such intentions, they have to understand the global practices and good consultants. Second thing I have seen in the hospital, the tapestry, upholstery, the pillow covers, mattresses, or the material of the mattresses and pillows, and especially when there are wards or the rooms where the 2 patients or 3 patients are kept in a particular class of the rooms, there the curtains or whatever tapestry used, it is not fire retardant or fire resistance. So that is again a very dangerous thing. So this is one area. Then you will find the electrical appliances or the electrical systems are equally in a bad shape. So loose wires, the electrical ducts, somewhere I could see the electrical ducts itself were dead trap. You cannot carry out the proper maintenance. Then maintenance is left for the outsourcing. Outsourcing is fine as long as the professional agencies are doing their job. But outsourcing cannot be the only way out. You have to have, at least the good hospitals will have to have their own staff, own arrangement that they can monitor it. They find, I think, the only ITI course, professional, the vocational courses done people, or the diploma holders. I'm not against any qualifications. Sometimes I have seen even diploma holders are much superior to MTech guys. So I'm not taking the knowledge with the particular person's qualification, but diploma holders, low paid staff, that is taken as a very secondary thing. We spend much more on the decorating of the hospital, the ICUs, and many other facilities. Those would look jazzy, and that would attract the people to come to that hospital for treatment. Then the HVAC system, when the air conditioning particularly is not, computed for the 100% 24/7 requirement. In fact, it should be more than that. There has to be a buffer. Then ICUs, there's a lot of use of sanitizers, ICUs, CCUs, or maybe the operation theaters, and that forms a sort of alcohol cloud there, and it settles down at the roof level of the particular room, and any small spark can trigger the fire. Their use of the other heating appliances is also not done properly. Sometimes I have seen even the good nurses, I'm not blaming any particular cadre or the particular profession, but they pull the pin from the socket with the cord itself. So this causes sometimes a spark, or it can really damage, or it can cause even the electrocution. It can damage to the person who is misappropriately using it. So these are the many aspects. And electricity never burns. But yes, the electricity can cause fires, and electricity is one of the major challenges in the hospital. When the fire audits are done, similarly, while doing the fire audits, when we do the fire audits for the hospitals, we recommend there strongly that the electrical safety audit should be done by the professional experts. And many places, even I have given the reference of Gopakumar and his organization called as NFE. So that thorough professionalism has to be there. And as a operational fire chief, having worked for more than 20 years in different areas and having come across the different hospitals, not actually the hospital fires, but the hospital fire safety arrangements and the recommendations thereof, I think we have to give thorough focus on the different aspects like HVAC, electrical fire safety, use of the life safety mechanism, and many other things. So with this, I will not stand too much between the experts, whom you must be all eager to listen to, and also the organizers. The organizers, I am grateful for inviting me and voicing my views from the operational angle and as a fire chief. And now experts will really highlight the issues related to preventive measures related to the electrical safety, and also the protection measures and what care should be taken. So I give it back to Lakshmi, and Lakshmi, you can proceed with your proceedings. Thank you so much. Thank you, audience. Thank you so much.
Thank you so much, sir. I would request Mr. Gopakumar to give a brief introduction about NFE and the presentation.
Thank you very much, Deshmukh sir. Thank you, Lakshmi, for the introduction. So today we are going to discuss a very critical subject of electrical safety, but I will start with a small introduction of NFE. Basically, NFE is a group of passionate engineers into the field of electrical engineering, basically into the electrical safety. We are a registered society, registered in Chennai, having more than 1,200 members at the moment. We registered an year back. We just completed 1 year of existence. Our vision is to make Bharat electrically safe. And to make this vision happen, we are having several ways, several methods, several missions. One is to train people, also to have accreditation systems in place, and so on. We have different divisions in our in NFE. We have trainings happening, training division, then product developments. We are supporting manufacturers to develop or to make their products as per the international requirement. We are also supporting the standards and the regulation making process. In last 1 year, we have conducted several programs. This year, we are going to have 18 one-day workshop seminars across India, also 2-day seminars on specific topics, and so on. We are very actively promoting or educating the market. It's a member-driven organization. Please go to the website of NFES, NFE, our website, and you can become a member. The membership is just 1,000 rupees plus the GST. Once when you become member, you can actively participate in several of our activities. So with this, I also one of the activity which we are trying to come up is the certification of electrical engineer based on ISO 17024 personal certification. So we have made or we launched a scheme for certification of electrical consultant, NFE certified electrical consultant, NFE certified electrical installer, NFE certified electrical safety verifier. We also approved the first PRCB. PRCB is the personal certification body. A company from Hyderabad. This has been already approved. You can find the details very soon. We will be publishing more about the certification schemes. We are also working out on several mass awareness campaigns. For example, a school, 2,500 schools and 250 engineering colleges. So such big programs we are doing. But anyway, without spending more time on the introduction, let me start the presentation. So today we are going to discuss electricity, how to handle electricity in hospitals. Very important subject. This subject is becoming, but again, just a small introduction. You can find on IEC MT40. This is the working group in IEC making global standards on electrical installation in medical location. That means how to design, how to erect, how to verify, how to test electrical installation in medical location is decided by this committee. I am a representative, or I am in this particular committee from India. Now, the subject is of high importance to you. I am just scrolling down the news which has come in the last 2 years. Fire, fire, fire everywhere in hospitals. So many incidents. If you look at the latest one last week in Delhi, if you look through these accidents, first of all, it's alarming. Second, for example, this particular video you can find on the video. This is a live video, a live example of a ventilator catching fire. As Deshmukhs are told, people are going to hospital to save their life, but the unsafe situation in this hospital is creating more problem. You can find these kind of videos, especially the videos which is creating fire in medical locations in YouTube. Several videos are there. In this particular case, you see the ventilator started burning. In first few minutes, there was a heat. Everybody identified that there is something going wrong. Then after some time, the fire starts, and after few minutes, the whole room is full of smoke. Most often, if you look at the fire, the report of such incident, always it says the fire is due to overload. As electrical engineers, please note that overload cannot ignite fire. During overload or short circuit, the device should trip. Protective devices are installed in the electrical circuit to trip. So electricity is not supposed to create fire. So now, coming to the subject, you can see this one. This is another fire from an air conditioner. In this particular incident, approximately 17 people lost their life. So hundreds of people are losing their life due to fire in the critical areas such as operation theaters or medical locations. Let me skip it. If you look at from the internet, you will get this kind of information. You can find, you see accident in hospitals. If you 2004 to 2010, there are several incidents, and please have a serious look on the incidents happening in India. Unfortunately, this is from 2011 to 2012. So many accidents, fire accidents reported from India, and most often it is air conditioners, one of the main reason. We were in our several training programs, we were explaining repeatedly that an air conditioner with stabilizer is a disaster. In case of a fault on the air conditioner, the stabilizer will not allow the protective device to trip. As a result, problems, the fire can happen. Now, the situation is really alarming. Why it's important? In medical location, all of us should understand that we are talking about patients, an area we have the patients unconscious, they are unresponsive, they are difficult to move. Patients are already in life-saving equipment, and many patients are there in one area. Severeness of the hazard, as Deshmukh sir told, it's a oxygen-rich area. Presence of alcohol is very high. So even a small spark could ignite a very dangerous situation. Almost 78% of the 33% of the 33 hospital fires happened during the recent time is because of electricity. Electrical reasons are creating more fire hazards in our nation, unfortunately. Similarly, another subject which is of equal importance is electric shock from the appliance or burns in patient's body. We should understand that the medical location is very critical to shock, where the skin is bypassed. Even very small potentials, small energies can burn the tissues, it can kill people, or it can create electrocution and so on. And conductive instruments are in contact with bloodstream or heart muscles. The floor is wet. Basically, we are talking about a highly sensitive, electrically dangerous location where such activities are going on. The challenges which we see after an accident or when we interact with various professionals in the medical industry or electrical installations in the hospitals, the challenges which we face, first of all, number one, the importance of electricity in medical electrical and medical electrical systems is not seriously considered, except the cost of the equipment. Everybody talks about the cost of the equipment. Of course, you are buying an equipment worth maybe few crores, 5 crores, 7 crores, but it is installed in a very unsafe situation. Understanding of electrical classification of medical locations, such as if we ask what is group 0 location, group 1, group 2 locations, then most of the time the understanding is quite less. Understanding on advanced safety measures in medical location. For example, there is an operation theater. Technically, we call it as group 2 medical location. So what do you do? What are the safety measures required in a medical location, group 2 location? Most often the answers are quite, the expensive equipments are installed, but it is installed in electrically unsafe conditions. Knowledge of the equipment supplier is a very critical subject. Lack of training, lack of experience, and lack of knowledge of the engineers or the technicians, those who are coming to install the product, those who are coming to verify the product, and so on. One example which we are fighting against or fighting with all the equipment suppliers are, most of the equipment suppliers come with an argument. 5 volt or 10 volt between neutral and earth is creating a failure of the equipment. For example, a class 1 equipment is tested to withstand all these measures. They are not aware. So the lack of knowledge of the engineer is very critical. Recommended maintenance and calibration measures are not followed. Mr. Atanu will explain much more about it. Then misleading information from authorities. Unfortunately, the government authorities are providing misleading information. Example is NABCB, the latest, I think, 2020 guideline. The guideline which is following this particular book, it says the help of new technology like thermal imaging equipment can help detect loose contacts in the system and thereby prevent a fire incident. This is quite unfortunate. This is not a recommended method in any of the standard. It's not, unfortunately, thermal imaging is not a recognized electrical safety measure in a medical location, in a hospital. You can do it, but don't think that thermal imaging can bring safety to you. It is something else. You can do it as an extra safety measure. Unfortunately, the information from the government or from the authorities is misguiding. Sometimes the circulars from various government departments to government hospitals to the central government writing to the secretaries of state governments, most of the contents are misleading. Trained staff, then if we ask for drawings, most often drawings are not there, manuals are not there. So basically, safety in medical location need a coordinated effort from a group of skilled engineers, engineering professionals in handling different challenges. Unfortunately, this particular, a group of several engineering professionals, experts in different field of medical engineering working together is unfortunately missing in our country. So now, how does the technical? What do we do to make the installation, make the premise safe? For example, I start with the identification of risk. First is for making anything, any safety thing. First, you should identify the risk. IEC 60513 explains the different type of risk involved in a hospital or in a medical location, such as a device inability to carry out its intended function, energies, equipment fault, and all the risks are identified in this particular standard. Now, the risks identified, hazard identification is number one. Then the security level, how much, what is the limit of certain hazard? Decide on acceptable risk level, fault avoidance and control, integrity levels. Basically, the risks are converted into engineering practices. And these engineering practices are again developed into product standard, process standard, installation and environmental standard, and application standard. So basically, it's a large engineering process goes behind each of the requirement, technical requirement. It is not like sometime I've seen in some of the hospitals, a supplier comes and claim that you make all your electrical installation digital. Digital electrical installation can save your place. This is not correct. Sometime, unfortunately, there was a circular from Government of India. It says that you put some IoT-based device, then the IoT-based device will protect all your electrical installation. These are mistakes. It's not like that. It is a coordinated effort of several people, several engineering practices, which is followed, and all these must be followed. In nutshell, for example, equipment versus the installation. Medical electrical equipment and medical electrical system, they are classified. Means the electrical apparatus which is used in a medical location. Most often, the power supply and distribution decide the safety of medical equipment. For example, safety of equipment depends upon the supply parameters as well. Sometimes disconnection, single fault condition. What is the single fault condition? I will show you from the standard. Then the second part, operation of protective device used in multiple supplies. Example, there is a DG, there is a transformer, there is an UPS. Please note, protective device may work in transformer. Once when the supply is from the transformer, the protective devices are ready to trip. That may work, but they may not work in DG and they may work in UPS. So the situation is not sure whether the protective devices will work in all the conditions. I just show you how these are transferred into the engineering practices. I'm sure you are able to see the screen, but however, I will share it again. I have, I'm sharing you the screen. Lakshmi, can you see the screen?
Yes, sir.
Which is showing the Indian standard, correct? Yeah, I'm showing you
Yes,
just
sir.
the
Yes,
word
sir.
single fault. This one is medical electrical equipment. That means the equipment which is used in a hospital has to satisfy these requirements. You just see single fault condition. About 200 times single fault conditions are explained. Single fault condition, I'm just skipping each one by one. Just let us look what is this single fault condition. Condition of medical electrical equipment in which a single means for reducing risk is defective or a single abnormal condition is present. In the sense, medical electrical equipment often should work under single fault condition. Now the supply, the electric supply to the medical equipment shall be able to handle it. And if it cannot handle, you end up with fire. And it is not a simple subject to handle. Say, for example, in this particular standard, single fault is explained in 215 places. 215 places. Similarly, the next standard, ISIC 62353, the medical electrical equipment, recurrent test and test after repair of electrical equipment. What do you do? How do you do the repair, and what are the considerations you should do? Here, for example, the single fault condition is explained 14 times. So basically, single fault condition to handle it is decided by the power supply. And if you don't handle the power supply properly, then actually you are in trouble. Similarly, the other Indian standard, example IS 17512, which is a very new standard, but of course the old version was also there. Requirement of electrical installation in medical location. The first two standards which I have shown are for the equipment, whereas here is a location where you are using that particular equipment. These locations, for example, I'm searching the term supplementary. What is written? If such disconnection time cannot be guaranteed, that means you are sure that the MCB is unable to trip or the protective device is unable to trip under certain conditions, it is necessary to take other protective measures such as supplementary equipotential bonding. You have to bond all the metal parts in the building, supplementary equipotential bonding. Like this, several safety measures are recommended in the standard. Very easy. You can download National Electrical Code of India 2023. You can go to BIS website, create a username password. You search National Electrical Code of India. You can download it at free of cost. It's a 750-page document. Now, part 1 of NEC is 100% applicable. You have to apply it 100%. Then you go to part 9. Part 9, for example, here part 3 section 9. Part 3 section 9 explains the requirement for medical location. So there are medical locations, additional safety measures are required. So basically we are talking about a very critical installation which can catch fire, and this particular installation needs several safety measures and the attention of several engineers or engineering practices basically. Accordingly, medical equipment are classified into class 1 medical equipment, class 2 medical equipment, sometimes with a metal body or sometimes without metal body. These equipments have applied part. Applied part means the parts of the biomedical equipment which is either touching the body of the patient or it is bypassing the skin and going even up to the heart. So these applied parts are classified. The dangerous part is, in case of any excess energy through the applied part, the patient may be electrocuted. Very, very critical situation. We will end up with very critical situation. So what we should do after every repair, you have to test, you have to calibrate the equipment and ensure that the energy is going into the patient is within the limit. Otherwise, it can create a hazard. The medical locations are classified into group 0, group 1, group 2. There are 3 types of medical location. Group 0 means a medical location where applied parts are intended to be used. No applied parts. There is no there is no applied parts used in group 0 location in a hospital. Group 1 means medical location where applied parts are intended to be used. External. Group 2 is a medical location where applied parts are intended to be used in applications such as intracardiac procedures, operation theaters, and vital equipment. So basically, depending upon the criticality of the location, there are 3 locations classified: Group 0, Group 1, and Group 2 location. Then, for example, the National Electrical Code, you can find this kind of a table. On the left side, you are seeing medical locations, different kind of medical location. For example, anesthetic room. You can find group 0, group 1, group 2. So anesthetic room is classified into group 2. So you need to have the safety measures recommended in that particular location. So like this recommended table you can find in NEC where each of the location is very clearly classified. For example, a group 2 location. In a group 2 location, medical IT system. Medical IT system means you just read, I have just copied from the standard from National Electrical Code. In group 2 medical location, a medical IT system, including medical isolation transformer and medical isolation monitors, shall be used for final circuit and where the same final circuit connected to ME equipment or an ME system located within the patient environment. So basically, during the first fault, your supply should not trip in medical location group 2 location. So such additional safety measures are very much included in the standard. An example I am showing, this is not the serial number 1 to 4 or 5 is not the entire safety measure, but just an example. Medical locations are classified into group 0, group 1, group 2 locations. TNS system or IT system may be required depending upon the criticality. Protective equipotential bonding, 50 volt in group 0 location, 25 volt in group 1 and group 2 locations are
Sorry to
necessary.
interrupt, sir.
Yeah.
Sorry to interrupt, sir. Everybody is calling me and telling like that your screen is not changing.
No. But what about you?
Yes, sir.
For
My
you,
screen
it's
is
changing?
changed now. No, sir.
Oh, you should have told this. Okay. Yeah, sorry. Is it visible now?
Yes, sir.
Okay, sorry for that. Yeah, let me go back. Okay. Now, okay, I was explaining this. Probably after this, the screen is not visible. Let me repeat it quickly. Depending upon the severity, see the medical equipment are classified into class 1 medical equipment, class 2 medical equipment, and each of these medical equipment have got applied part. Very critical applied parts are the parts of the biomedical equipment which is used on the body of a patient. So these devices, these applied parts have energy and the energy goes into the body of the patient. And if the energy is more, it's very critical. As a result, the patient can get shock or it can ignite fire and so on. So the equipment is very critical on one part. On the other part, the location, medical locations are classified into group 0, group 1 and group 2 medical location. Group 0 is a general area where there is no treatments happening. Group 1 is a location in which the applied parts are used external to the body of a patient. Group 2 is a medical location where applied parts are used internal, that means inside the body of the patient. So very critical, the groupings. And the National Electrical Code has got this kind of a table. You can find the different type of medical locations, the classification of each of the medical location, the recommended medical grouping or group of rooms. For example, hydrotherapy room is a group 1 location. Operation theater is a group 2 location. Anesthetic room is a group 2 location. Angiographic examination room is a group 2 location. Nuclear medicine is a group 1 location. So basically, different locations are very well defined in the standard. The safety measures required in each of these location varies. Group 1 location need additional safety measures. Sometimes group 2 location need some more extra safety measures. I have shown in the standard single fault condition in the IS standard. Single fault condition in the sense the equipment is faulty or there is some fault somewhere in the installation. The single fault could not ignite disconnection. The process should continue. That is the basic. Example, in group 2 location, medical IT system is required. Medical IT in group 2 location, medical IT system means a power supply which ensures that even in case of single fault, your device need not have to trip. So that is how it is. So basically, the additional safety measures required are medical location classification, the type of system earthing, type of equipotential bonding. Basically, additional bondings are required within the group 1 and group 2 medical location. Continuity of supply, electromagnetic interference. So there are several measures. These serial number 1 to 5 are not the entire one, but this is example of some of the safety measure required in the medical location. So very critical. Now, what happens actually? Actual practice versus recommendation in the standard. Example, I am taking electrical safety audit. In most of the medical location or hospitals, electrical safety audits are done. For example, one day somebody is coming, he is looking into all the panels, a general inspection, walk from one end to the other end. Then they check the resistance of sometimes the earth electrodes, then they make thermography. This is the general practice, unfortunately. Serial number 2, that is earth electrode resistance measurement, it is removed from the standard few years back. It is removed means you don't need to, if you want, you can do it, but don't expect safety from that. Number 3, thermography is not recognized as a safety measure in National Electrical Code for a hospital. What we should do? The NEC is recommending 19 inspection points and 11 tests in group 0 or in general locations of a hospital. Then additional verifications are required in group 1 and group 2 location. You are supposed to carry out all these inspection process. It is not like somebody coming and walking around and making a general inspection, testing few earth electrodes and making a thermography. Unfortunately, the accreditation system in India are yet to consider electrical safety measures. So far, there are some wordings the management should keep electrical system in a safe way. That's all. But the process recommended, for example, instead they give wrong information. Example, in the NABCB guide, what is written is the help of new technology like thermal imaging equipment can help detect loose connections on the system, thereby prevent fire incidents. Unfortunately, this is not the correct way. For example, I am showing you again the same part from the accreditation system, the intent of electrical safety audit, and you see here help of new technology like thermal imaging. And the guide also says this shall be incorporate statutory requirements where applicable. National Electrical Code of India could be used as a reference document. Unfortunately, NEC is used as a reference document. Even if it is used as the reference document, none of the safety measures in the NEC are included, unfortunately, in the electrical installation. So basically, safety is you should not compromise. So compliance to NEC 2023 is a legal requirement. Now it is not a recommendation, not a reference. National Electrical Code is not a reference document. It's a mandatory legal requirement. So with this, I would like to stop my presentation. Over to you, Lakshmi. If anybody wanted to get in touch with us, please note the email address. You can get back to us. Over to you, Lakshmi. Probably you can invite Mr. Atanu.
Yes, sir. Oh, hello.
Yes, we can hear
Mr.
you.
Atanu, sir. Yeah. Mr. Atanu, sir, over to you.
You have to unmute Mr. Atanu. You can
Hello.
speak.
Can you all hear
Yeah.
me?
Yes.
Yes,
Okay.
sir.
Hi. Good morning. Good morning, everyone. And thank you for thank you to Gopakumar and NFE for giving us such a relevant subject for this webinar. So with that, I'll just start my presentation. I'll start sharing my screen. Let me know once you are able to see my.
You can see your screen.
Yeah. So for this day, so basically it's interesting and definitely very relevant subject for the way the hospital or the fire incidences that are happening. Some are recorded, some are not even getting recorded. So basically, what is the need to have this kind of safety audit or medical device safety? I'll focus into the medical device safety and how this, if the device is not properly kept safe, and what kind of hazard and how it can lead to even fire incidents, and definitely injury to the healthcare providers and patients. So definitely, I'm sure all of you are here and you agree that everybody wants a safe environment and the medical device is safe. Okay. And secondly, the device which is connected to a patient, it should work in it should give an accurate result. Okay. Every time I mean, whether it is 1 year old or 5 years old or 7 years old, it should give the accurate result, and it should be ready for the patient use. So in that case, ideally device needs to be tested more often as the device gets old. So what are the things that generally on a broader scale can even go wrong? So, okay, so there can be fire incidences or some, because as Gopa was telling, like there are like water and gel, and is a highly conductive environment in a hospital. Okay. So these kind of incidences can happen when even the water and the dust build up in a connections, and that also can create some kind of fire incidents. Okay, from various medical or non-medical devices connected or installed in a hospital. With that, I mean, these are the some kind of hazards that were recorded. I mean, there will be many more, plenty of that, I'm sure. People who are from hospitals, they would have seen a lot of this kind of incidences wherein surgical diathermy causing a lot of damage to the patient's body and so many other things, right? Even a CT scan, excessive radiation can create a hair loss to a baby or even a patient's. Okay. So what is safety? Okay, electrical shock hazards in a hospital environment, where it can come from. Basic, it can start from a hospital bed, OT bed. Nowadays, everything is electromedical or electromechanical. Most of the hospital beds in a operation theater, these are OT. Operation theater, these are electrically operated, and hospital beds are also electrically operated. Then, as Gopakumar was telling, like patient monitors and all those things, these have applied parts, right? So this will create a electrical shock hazards. Ventilator, anesthesia delivery system, electrosurgical unit is again is basically we are doing incision inside the patients with the electrical surgery, that monopolar electrode, and the high amount of energy is going to the patient, which is even with the, if the return electrode, or it can even can cause primary or secondary burns to the patients. Syringe pumps, transesophageal probes in ultrasound machine, which goes inside the patients. Okay, so that can create in a leakage current from a TE probe, that can create definitely huge damage to a patient. So as you know, so we are dealing with human body, so it need to be extra critical. As everyone, when you walk down to a hospital when you are sick, we depend a lot on a hospital that we get the best things, and we at least the environment will be safe. We know everybody desire, or everybody, that is what they target, or that is what they at least tries to do. But idea is that how we can ensure that we at least we achieve that. So what are the kind of electrical shock, and how much is basically can cause a kind of shock? Okay. So a mild shock, what are the mild shock? Even anything below maybe 8 to 10, 1 to 10 milliamps can be, is a trip little bit, you, and little bit more when you are going more than around 15, 20, you can see a little bit of severe shock. And mostly anything nearly 50 milliamps, it can definitely be a very dangerous thing to a patient. Okay, as you know, anything something around 50 milliamps, 60 amps, basically a normal home fluorescent light will glow. So that kind of current, if it goes, definitely it will be catastrophic or dangerous, very harmful to the patient, leading to a death also. And all these things depends what is the duration, how long the patient or the human being is exposed to the current, and the path of the current definitely depends on all such things. So depending on this, based on the small background that I have given, so I'll bring it to you to the electrical IEC standards and how the IEC evolved for medical device. So as you know, electrical International Electrotechnical Commission, it was beginning. If you see, there was some data with the IEC that even in 1970s, I mean, these data are not definitely in India. In India data, maybe most likely it will be much more than this. Something around 1200 per year were electrocuted in a hospital due to poor design or whatever medical equipment. And during 1977 is when IEC has come out with 60601, and with a certain standard. So 60601 is the standard which was firstly designed for the medical device, design and medical device product development. So this was mostly for the product which was coming out and being sold in the market or for the patient healthcare. So IEC has given a platform with the bare minimum design specification which needs to be there. Okay. So for each and every medical device, whether it in an ECG machine or a CT scan, everything there are IEC subclause. So IEC 60601-1, it will have further subclauses based on the medical device. So this thing was last updated in 2011. So another update is expected by we in a year or so. So what is where is the it is applicated application is IEC 60601 is as I said in the previous slide, like it is for medical device design and validation tests that are not routinely repeated. Production is mostly for the device manufacturer, R&D, production and production line assembly. Hospital may or may not. So beyond that, slowly IIC understood that there needs to be some other little bit more. I mean, IIC 60601 was more stringent, and they thought that when in a hospital environment, when the tests need to be done more repetitively, there need not be such a stringent kind of testing may not be required. That's when they had come out with IEC 62353. Okay, so IEC 62353 is mostly for the hospital or the medical device service team service engineer, which was taken which is basically designed for non-repetitive and recurrent tests, so that when it is done, it saves time, it can be done much faster, and chances of these repetitive testers making any negative impact on the medical devices rolled out. So that is why 62353 had come into picture. So IEC defines like my previous speaker was telling, some all devices like class 1, class 2 and class IP, which are basically internal power source. So why this classification? So like class 1 is live part covered by basic insulation, class 2 is double or reinforced insulation. So based on the type of medical device, the testing requirement changes. Okay, what kind of electrical safety testing one needs to do, or the recommendations changes. Okay, so how do you understand which device is what? So if you see any medical device, on the back side of the medical device, if you turn it around, you'll be able to see these symbols. Okay, like a class 1 medical device will be on the top left, and the bottom it is like a class 2 medical device. So this is how you'll understand this is a class 1 or class 2 medical device, and this will help you in your decision and what kind of testing I need to do. Okay, most of us basically electrical safety generally understanding is that uh, we'll do some tests, we'll do some multimeter, we'll use the multimeter and we'll see some voltage and current, but that is very bad. That is not actually what in medical device how it has to be tested. Apart from that, all medical devices are again classified based on the kind of applied parts are there. So applied parts are the parts which are basically connected. Suppose a medical device, suppose the ECG machine, the ECG electrode is a applied parts. Suppose even a pulse oximeter oxygen sensor is a SpO2 sensor is a applied parts. Okay, defibrillator pedal is a applied parts. So which directly gets connected to the patient. So based on the applied parts, again it is classified. So why it is classified? Type B, B, BF, CF, so that equipment, again as I said, that IEC recommendation changes based on the type of the equipment. So it is very important that one understand what kind of medical device they are testing, and based on that they follow the proper guidelines. Okay, so these are the certain simple flow chart that is that we have done actually. So when you have a test equipment and the duty, the device under test, or suppose any medical device and the test equipment of electrical safety. So here whatever I'm showing, this is part of the electrical safety testing of a medical device. So when you talk of a medical device, you need to test electrical safety. You need to test electrical safety is paramount and most important, and it is the most common thing has to be done across any medical device, whether it is a basic ECG machine, or whether it is a defibrillator, or it is a heart lung machine. Anything and everything, electrical safety is That is paramount and basic. And then next is yours parameter testing. Particular machines will have other parameters, okay, like measurement parameters, like a defibrillator will have flow, pressure, your breath parameter. So based on that, you have to have those kind of parameter testings. Okay, that is like functional testing of the device. So as I was saying, like ISC has given the guidelines for just few slides back. I had shown that what are the types of medical device: type 1, type 2, and the based on that, and further is the type B, type BF, type CF. So what is this NC and SFC? Like Mr. Gopakumar was saying, like one is that normal condition and the single fault condition. So normal condition is the actual condition when the medical device operates. Okay, so what should be the earth leakage current, touch current, patient leakage current, everything is specifically given. Now when there is a single fault condition, and machine or is not tripping, is working, still it is working, ideally probably it could have stopped. So in the single fault condition, again the current goes higher, but still how much higher it should go, that is also defined in the standards. It anything should not go, suppose the machine is in single fault condition, it should not be more than, suppose earth leakage current, it should not be more than 10 milliamperes. Even patient leakage, if it is a DC, it should not be 50 microamperes. So as you have seen that AC currents are more, so DC currents generally are less. So accordingly, so for every type of equipment, type B, type BF, type CF, clearly IC has given the recommendations, and for the normal condition and both for the single fault conditions. So basically just what all and bare minimum you need to do, and what all tests you need to do. So ground wire resistance, leakage to ground, chassis or touch current. So you might be there might be some query like why chassis or touch current, how can be a touch current. Suppose you have a patient monitor or a ventilator which is having a, it is mostly these are low plastic bodies, or it is non-conductive body, but why there will be current in that. So as you know, it can have a capacity. Suppose human bodies are highly we are highly conductive, and beside below the machines inside will have all conductive parts. So it's like a capacitor. So conductor and the insulation, so it's like a capacitance. So ultimately when you touch a medical device, there can be capacitive current. So again IEC has given a guideline what kind of chassis or touch current should be there. Okay, so we have a detailed safety chapter on this, so which you can refer in our website. So I'll take you to a scenario wherein fire risk, a simple fire risk from a defibrillator, how it can trigger. Okay, a patient at the ICU needed to be resuscitated for whatever reason, for a cardiac arrest, and there was a intensivist has pulled in the crash cart and used a defibrillator to give the energy. And if you see interest, the unfortunate part is that during the electrical spark arc from the paddle, the patient, as high impedance gel was mistakenly used. These sparks from defibrillator ignited body hair spread to the linens, and that is patient gown, blanket, resulting in a fire. Okay, and several fire accidents. So this kind of incidents probably are there. Several fire incidents are there, which probably we are not able to understand why the fire has happened, because most of the time you will not have resource, or you don't go or deep into this, or deep dive into the kind of problem why it has happened. Okay, because as you understand, this ICU setups or OT setups are highly insecure in conditions like short circuits, medical equipment, capacitors, and they have oxygen cylinders. Any kind of blast or fire can further ignite the, it will magnify the situation. Okay, okay, so one more situation, I'll just one more case study probably I'll explain here is vaporizer malfunction. This is also a case study which was done in 2005. How a vaporizer malfunction can probably if you are all from hospital, you would have seen this kind of cases more often, or some cases you would have seen. A 36-year-old woman underwent a surgery for a simple arm. So desiflurane vaporizer was set for 3.5 to maintain anesthesia. And after 5 minutes, the patient became oxygen deficient, and she had a cardiac arrest. The ECG machine, which was ECG monitor, which was connected to the patient, it showed the patient has heart has stopped. So of course, patient was subsequently medically treated and resuscitated, and defibrillator counter shock was provided. And subsequently, further diagnosis show that patient has a accumulation of fluid in a lung, and all such complication has happened. Okay. So further, when it was analyzed, what was the reason for this kind of patient going into the coma? So it was understood that there was a crack in the vaporizer, which has resulted in the patient has received 23% disoflurin instead of 3.5. You can see, so how much, I mean, extra disoflurin has gone to the patient, and because of that, patient has gone into basically coma. And vaporizer could have been removed from the use. So had the concentration, or had there been a proper check, so this could have been 100% avoided. Okay. So there are machines there are test equipment available, like we also have, so which can test this kind of devices, this kind of products. Okay. So again, like what kind of thing has happened, in some of the hospitals in India, and what was this kind of fire, why it has happened? So it was suspected to be a ventilator blast. One case, Gopal Son, and one more case was there inside the OT in PGI. There was a ventilator blast which has caused the fire. With that, like, I'll come into the basically what kind of precaution and how the testing can be done. Okay. So any gas flow, I mean, products. So there are gas flow analyzers available in the market with us also, and those kind of products can be used to test what all you can test. If you have a ventilator or gas flow analyzer, it can be used for testing any kind of ventilator, anesthesia machines, anesthesia workstations, products like insufflator, oxygen concentrator, and you have the flow meters inside the hospital, wherein various pressure gauge, flow meters inside the hospital, various places. So you can check all those things. Any kind of leakage, you can basically um, identify it much before then it becomes an accident. So when there are periodic checks, because if there is an oxygen leakage from, suppose, one of the oxygen uh, flow meters or pressure regulator, pressure gauges inside the central pipe gas lines, okay, oxygen pipelines inside the hospital, inside the ICU, and if that goes undetected, if it was not detected, definitely if there is any spark, small spark, that will again add into a fire. Okay. So that is why this kind of testing, regular testing, can prevent this kind of extreme and unfortunate incidences. So basically one test device can help you in testing so many devices. So like ventilator, anesthesia, then your flow meters, then your insufflators, and so many other devices, including a suction, basic thing like suction machine. So further into this, like what all you must be knowing, but still I'll just reiterate, like ventilators, component failure can be Y test. Basically Y test is like component failures from ventilator, both in which are used both in a ICU or in a OT. There can be leakages from the interlock system or from the vaporizers, the scavenging system not working properly. Okay. Then adjustable pressure limiting valves, flow meters. So these are the some of the areas wherein, because OT and ICU is one of the two places wherein so many medical devices and are used continuously 24/7. So these products, when used and when not checked properly, and most of the cases nowadays is because of so many factors, hospitals are outsourcing lot of things to the third parties. So is a time to even check whether some of the critical things hospital can, apart from the outsourcing, whether they can do, as Gopakumar was telling, like once in a year, once in a day, somebody comes, inspector or somebody outsourced person comes and checks. Is that enough? We have seen enough cases that it indicates, it shows that it is definitely not enough. There are good and reputed hospitals who have already started doing their own in-house some of that basic testings, which they are finding much value out of it, because it's helping them in becoming more confident, believing their systems, and being more confident when they are facing the difficult situations. Okay. And it is time even for others also, if they have to improve the ultimately the overall safety inside the hospital, inside the building parameters so there is a need to have some of the tests or some of the things more repeatedly than once in a year activity. Okay. So what are the standardized practice one can follow? It's like obtain and standard requirements for minimum performance and safety. So how do you obtain? One is the international standard. Just now I have talked about something from IEC, but apart from that, OEM guidelines or OEM service manual is the best place wherein you can get what are the standardized procedures or bare minimum things one need to check. Okay. And when it is a ventilation, definitely you need to test apart from electrical safety part of it, you need to check other parameters also, like ventilation, all modes of ventilation, test all points, all ranges. That is very, very important. Okay. And standardized test procedure, and you keep the procedure for you, so that next time when you have to do it, you know what are the procedure you need to follow, and record that procedure. Okay. So what is the best practices is the consistent inspection frequency. So I'm just coming to a subject called, we mostly have seen the hazards and in the hospital, and how it can be mitigated, how it can be better understood, and how it can be better steps can be taken. Like there is something called risk assessment. So how do you define, or how can you have your own risk assessment? Okay. Fluke Biomedical, or we have some analysis, some studies we have done along with University of Vermont. So based on that, we have five criteria of designing the risk assessment for a particular any particular medical device. Suppose for a ventilator here, what is the clinical function of the product? What is the physical risk from the product? What is the problem avoidance probability? And what the incident history shows. So like a clinical function from a ventilator, if you say it's a device of life support, so your score is 5. If it is a device of life support, it automatically becomes 5. Similarly, for even for a defibrillator also, it will be 5. Again, physical risk, even if the device fails, where the patient can cause to patient death, definitely ventilator phase it will have, so 4. So accordingly you give a rating, and anything score of 13 plus, it shows at least bare minimum it should be tested vigorously twice in a year. And anything between 9 to 12, this is suggested, this is not a, I mean, this is what we have suggested based on our studies, and that is also likely uh, in which we have done in US. But this is you can have your own, you can follow this, or you can have your own risk assessment also based on your uh, experience, and based on the, like there is something called, we have like provide evidence and incident history. This is most important, one of the criteria. So whether the incident, whether the device had a significant history of failure, or giving some kind of erroneous things, or safety hazards like creating um, fire and all those kind of things. So that kind of incident history, definitely you can help, it can help you in coming into this kind of scores. Okay. So similarly, for a defibrillator also, we can have this kind of risk assessment done for a defibrillator. So clinical function, physical risk, okay, and the problem avoidance probability. So based on that, defibrillator was given a 13 more. So which also means that it has to be tested at least once in 6 months or twice in a year. So semi-annual. So So we have this risk-based detailed study which was co-authored by University of Vermont along with Fluke, risk-based determination maintenance frequency of all medical device, and the intervals are established for the safety of the patient. Okay, And this system is built based on the data, previous data, which are available with the US FDA and various other medical device agencies. With that, I'll suggest, if you can go through, if you want to understand more in these subjects, you want to have more training or more understanding, there are detailed webinars, detailed training modules are available in our website. There is something called Advantage Training in our website, flukebiomedical.com. So you can these are all free. You can go and register yourself and take advantage of those training modules. Okay. And we are happy. If you want to have any feedback, any comment, you can reach us to us, and you can mail us to us also. Okay. With that, I'll end my presentation. Any questions also, you are welcome to raise here.
Thank you, Mr. Atanu. So we have a lot of questions. First of all, we would like to inform you that participants, those who are joining after 500, because we have much more participants today, they will be directly routed to the YouTube channel. Now, if you are routed to the YouTube channel, probably you may not be able to ask the questions directly here. So in question answers, we have a lot of questions. Mr. Atanu, if you can unshare yourself. At the top, you see stop share. There is a red button at the top.
Yeah. Just,
top.
Yeah.
Yeah, thank you.
Done.
So there are a few
Thank you.
questions, and one of the serious question which several people asked is about my two controversial statements. The controversial statements are, the first one is thermal imaging. How did you say that thermal imaging is not recommended? Let me share the screen now. I'm sure you are able to see the screen. I have opened the National Electrical Code of India. So this is a comprehensive document. It consists of several obligations. Part one.
Yeah.
Lakshmi, you can see the screen, I hope.
Yes, sir.
Yeah, thank you. So I'm showing the National Electrical Code of India. It's a 750-page document. I am taking you directly to page number 255, which explains the verification, what you should do. This is part 1, section 17, verification of electrical installation. Now, systems up to 1000 volt AC and 1500 volt DC. It consists of inspection and testing. Inspection shall include the checking of the following where relevant. It talks about method of protection against electric shock. You can find out so many information. If you download NBC, you go to page NEC, you go to page number 244. Look at clause number 4.2.3.3. This is about the inspection part. So now you can see here A to S are the inspection. Then after the inspection, we are supposed to go to the testing part, testing above 1 kV, now below 1 kV. You scroll down. Yeah, testing 4.3.7, low voltage system up to 1000 volt AC, 1500 volt DC. Now you can find the serial number, a continuity of resistance of conductors. That means if you measure the continuity resistance of the conductors, all loose contacts, including the resistance of the earth continuity conductor, will be very clear. The resistance of the wire plus the loose contacts will be very clearly understood, and it's a mandatory requirement before you energize the electrical installation. Insulation resistance, second insulation resistance of PLV, SLV insulation resistance, the effectiveness of floor and wall resistance. That means people, those who are standing on the floor, is not getting a shock. Effectiveness of automatic disconnection of supply, and up to voltage drop. There are different testings included in the standard for a normal electrical installation. Now, medical location, what you should do is you should go to part 3, section 9 of NEC, requirement of medical location. Here you go to clause number 9, verification, the additional verification. Please note that these verifications are not for the equipment. NEC is talking about the verification of the whole installation, means the wiring, the devices used for safety and so on. Now here the inspection, you can see here, initial inspection, initial verification, functional test of insulation monitoring device, measurement to verify supplementary equipotential bonding, measurement, like this. There are several verification measures included, also periodic verification. So it is not one measure, it's a sequence of several multiple tests, multiple verification you are supposed to do. Now I am checking the word thermal imaging, let's say thermal imaging. In the whole document, you cannot find any word of thermal imaging. Now I am searching thermography. So thermography is used in one place. You see here, part 1, section 22, here as a note it is included. Documentation is not necessary for work carried out outside the restricted boundary of task like visual inspection, thermography, etc. That means documentation, if you are making thermography, you don't need to make the documentation is what is written. This is also not as a part of it, not as a mandatory requirement. Thermography is not recognized in National Electrical Code or in any of the low voltage electrical safety standards. It is not recognized. Now I am taking you to IS 17512. The word thermography, of course, it is used for massage thermography. That is not the thermal imaging, but something else. So the word thermal imaging or thermography itself is missing from all these national standards. So the first statement which I wanted to tell you is, I didn't made any controversial statement. The statement, my statement, thermal imaging or thermography is not recognized in the standard is a valid statement because it's not recognized. It is not going to help you anyway according to the recognized safety measures. So I go to the next second, probably the controversial, because somebody put in the comment. So I'm reading the second controversial, the wrong information given by authority. Of course, yes, I know everybody looked very seriously into, for example, accreditation by various agencies. My statement was accreditation agencies didn't consider electrical safety. Of course, yes, they have written somewhere in one line, the installation shall be safe. Under that, it is written as latest technology like thermal imaging can be used. I really don't know from where these mistakes came into government document. So with this, we would like to go to the question answers. I hope my answers are clear. So, Mr. Atanu, can we take up a few of the questions? You have to unmute yourself.
Sure, we can take.
Yeah. The first question is, okay, from Mr. DK. He is asking to, let me explain later. Please elaborate electrical distribution in group 2, group 1, especially RCD provisions for the final circuit. This is by Mr. Bhushan. Mr. Bhushan, you can go to NEC. In part 1, section 9, this particular requirement is very well explained, where to use RCD, where not use RCD. Actually, if we give an answer in a webinar, sometimes it may be misleading. So I strictly request that you go to the standard, you can read it and understand it. Similarly, elaborate electrical installation do's and don'ts for OT and ICU. Actually, I'm not an expert in that particular case. I can only explain what about electrical. Shatanu, can you the do's and don'ts for OT and ICU?
I mean, as far as medical devices are concerned, I can tell at least for the medical devices part, definitely for any medical device which are used, suppose inside the OT or even ICUs, as per IC, it needs to be tested at least for the electrical safety part. Okay. As I have told, IC 60353 is the best thing to follow for this repetitive and recurrent tests. So even like I'll tell something like surgical diathermy, cautery, ventilator, anesthesia workstations. OT table everywhere. OT table is one thing from where a lot of burn cases are happening, because nowadays, suppose a patient is operated with a electrical surgical diathermy, and the patient is a part of the electrical conductive part, and when the patient body touches any part, metal part of the OT table, then and it becomes a high concentration of electrical current going in, resulting in a burn in the patient. So those kind of things has to be checked. So it is one thing is that it needs to be basic safety. Should not touch the patient. Body should not touch a open metal this object. Apart from that, also there are so many other things that needs to be checked in a surgical diathermy. Like there is something called patient electrode return path. So there are entire set of tests that can be done, or ideally should be done. So there are analyzer test equipment which are available for those. Okay. So this is one. Ventilators. There are so many other equipment, suction machine, everything ideally should be tested. Okay, more periodically, because these are all life saving. That OT and ICU is two critical, most critical areas, right? Even ECG electrodes which are there when a patient monitor is connected to a patient, ECG electrodes are, I mean, you have to see it's applied parts, right? You have to see in the ECG electrodes, the leakage current and everything it has to be done, which is defined as per the standards.
Yes, thank you.
Sorry,
Yeah,
I wanted
Ravi,
to
go ahead.
give the brief history. As per the IEC 62353, it has been clearly mentioned what are the things to be there in the OT room and ICU rooms, how it has to be followed and all. Actually, what is happening in OT rooms and all, there are a lot of fires hanging around. It is laying on the floors, all these things. You need to know all those things has to be avoided. How can we avoid those things? And then spillages around the corner, and then even in the centers, like gel is spilled out, spirit is spilled out, ethylene dioxide is spilled out. All these things has to be avoided as much as possible. Those things has to be avoided and make a proper procedure how what it should be. Then only it will be correct. Okay, it depends on the how the OT is been arranged. Then only it can be. You can write down what are the procedures has to be followed.
Yes, thank you, Mr. Ravi. I think these procedures are already included in the respective ISO standards of those equipment
Yes.
or equipment location. It's already there. Only thing is we should start following up. We should start doing it. Yeah, thank you. So can I go to the next question, Mr. Atanu? Yeah.
Yeah, please.
So
Please.
somebody is asking a suggestion. Mr. Vikram Tongolkar, Mr. Gopakumar. My question is, observation is that the issue starts with the incorrect design of building. Okay, Mr. Vikram says it's all because of the incorrect design of the building and so on. Of course, it is not in all the cases, and yes, in some few cases, the incorrect designs. So this is not a question; it's a statement. Then let us go to Mr. Anand, Dr. Anand Sharma, Anand Mishra has asked, if not thermal imaging, what would be used in hospitals for screening of audit of electric? Dr. Anand, probably the question is clear because several people asked the question. I explained from the National Electrical Code. Please note that the National Electrical Code is a legal requirement now. It's not a recommendation or reference book. It's a legal requirement. Also, Mr. Abin Thomas had a detailed question again on thermal imaging. He says, the predictive measures thermal imaging can save. But Mr. Abin, please go through the National Electrical Code. Very clear explanations are given. So Mrs. Pallavi has asked, can we get to know the standard, one uniform standard and code for fire safety audit and electrical safety audit for hospitals in India? Unfortunately, Ms. Pallavi, this is not existing until now. Probably in the upcoming National Building Code, both sections may be giving more information on this particular subject. Then Mr. Niranjan has asked a quick comment from expert on whether multiple earth pits are okay to be in the hospitals. Mr. Niranjan, I would like to put it in a simple way, not multiple earth pits. Instead, I would say not even one earth pit is necessary for the electrical installation to make it safe. That is why in IS 732, which is also a supporting document for National Electrical Code, it's very clearly written that an installation may have an earth electrode. May have an earth electrode. Means sometime, for example, for lightning protection, you may need an earth electrode. Otherwise, earthing has nothing to do with the earth electrode in soil. It is a totally different subject. I hope the question is clear. So not multiple, not even one is required is the answer. Again, Mr. Niranjan, also role of supplementary equipotential bonding in electrical safety, medical equipment and medical electrical installation. Of course, supplementary equipotential bonding means in group 1 and group 2 medical location, that means critical areas, all the dead metal parts must be interconnected in such a way that patient or the people, those who are working, they are not getting shock from the energies or produced energies from this equipment. So we have to interconnect the different metal parts. And the metal parts, this interconnection shall be tested with a meter of 10 amperes or 25 amperes, and it should show a resistance of less than 100 milliohm. That is the technical requirement, Mr. Niranjan. Then, yeah. Okay, since stabilizer is a disaster in AC, how can overcome voltage fluctuation be in issue without stabilizer? Of course, nowadays I think the inverter air conditioners are capable of operating with a larger potential, voltage range. Mr. Ganesh, my question to Deshmukh sir, as per Chennai High Court order, ramp is necessary for ground plus upper floor hospital building. So ramp is so important for evacuation purpose, probably spelling mistake. Please give your opinion. Sir Deshmukh sir, are you listening, sir? There's a question from Mr. Ganesh. He's asking, as per Chennai court order, ramp is necessary in hospitals. I think you have to unmute, sir, if you are listening.
Sorry to interrupt, sir. Due to some emergency, he had to leave.
Okay.
So he is there. Sorry.
So also Mr. Mahendra Chilikuri says thermography is a routine test. Mr. Mahendra, sorry to say that it is not a routine test. As per the standard, whatever not written in the standard, if somebody is doing thermography as a routine test, our point is only it is not recognized in the standard. If somebody does, it is up to them. It can be done in overhead lines and external solar PV. Yes, it is recognized, not for within the building, especially less than 1000 volt AC, 1500 volt DC. So further questions. Lakshmi, we have a lot of people, those who have shown their hand for the
Yes, sir.
discussion.
I'll allow
Probably
them to
can I on? Also, Mr. Ullas Vajre told IS standard IS 16168 has written thermography. Mr. Ullas Vajre, please look at the heading of that particular thing. Unfortunately, the chemical engineering department or some other department of BIS, not the electrical department, has made a standard on infrared thermography of electrical installation. Unfortunately, this is not recognized as a part of the electrical verification procedure. Sorry for that. Yeah. Mr. Atanu, few more questions are there. If you can go through the questions, if you can take a few questions.
I'll have a look.
क्या
Yeah,
ये
just,
ये इसका ये है इसका ये है इसका ये है ना तो ये कितने चार पाँच
so there is somebody asked, there was last from Karthik, share the important IC numbers for reference. I mean, important IC, we said like IC 62353 is the important for medical device. Now for electrical safety and all medical device testing part. Okay, that is what is required for the hospitals. And 60601 if you are a medical device manufacturer or you are designing a medical device. Okay, and then further classification is there. You can mail it to us. We can respond to you.
There are different this one, there is actually the electrical is a basic test which is being told, and next is a functional test. One is the safety test, next is a functional test. Safety is IEC 60601-1 is a safety test. Safety is a first preliminary and it has to be followed for all the equipment. For each and every other equipments like incubator analyzer, if you are going to do, there is a class that separately it is called as a functional test. IEC 60601-19-20-21. 19, 20, 21, there are 3 tests. Like that, if you are going to do the defibrillator, -7, -8, like that it is there. For the X-ray, there are different tests. Like that, there are different, almost around, I feel around 260 or 270 IEC standards are available. Each one has to be bought actually. Nobody can share it actually. And you can go through the list by Googling it or anything. Or if you want only the list, we can provide you. Please write to us. Actually, I have to Karthik, I have sent the email ID. Let him please write to us and we will share you the list. What is the list is available. Okay. Thank you.
Thank you, Mr. Ravi. There is one question from Mr. Durai Swami, which I would like to address. Is IMD, insulation monitoring device, must for Group 1 and Group 2 location? Please, is there any guideline by NABH? Mr. Duraiswamy, the National Electrical Code, yes, in Group 2 location, not in Group 1 location. In Group 2 location, medical isolation or IMD is mandatory. It's not IMD, it's medical IT system, which includes insulation monitoring device. So the wording we have to use very carefully. Now in Group 1 location, if any equipment, a supply failure or single fault in any failure could ignite a problem, then in that location you need a medical IT system. So now, if any of the participants, those who are interested to speak, I think Lakshmi has made you to speak. And if anybody is interested to ask any question, please feel free. You have to unmute yourself and you have to ask the question. Mr. Karthik, Mr. Raj Ratna, okay, Mr. Krishnamurthy,
Mr. Vikas, so many people have raised their hands. If you want to ask, please go ahead and ask.
Lakshmi, probably these are, probably they have raised the hand by mistake. You can allow others and you can remove them from the.
Okay, sir.
Yeah. Dr. Chiliguri, if you have some points, you can.
Okay, good morning, everyone. Okay, that I mentioned one point actually. These medical equipment, of course, need to be tested using various standards, and some of the equipment need to be tested regularly or more often. But I would like to know, is there any mention in these standards or guidelines 0-hour testing? That means when an equipment is not in usage, is there anybody doing this? Because I see this, not even the medical equipment, everything as an asset monitoring. And if asset is not monitored continuously, sometimes you can do regularly, monthly or bi-monthly or annually like that. But an equipment should be available when there is a need. And after every usage, anything can happen to the equipment. And it may miss the, the standard guideline testing procedures protocol and end up in resulting in failure or mal-operation, or maybe due to some other reason. So I think is this IEC standards or ISO standard, do they have any 0-hour testing facility? Because if when equipment is not available for usage, if equipment is not in usage, is there anybody testing? I think, and all these hospitals also need to have a testing facility, testing and maintenance facility, so that they are all dedicated and equipment, whatever they have, is it in good shape before and after the usage?
We understood the question. We understood the question. You are asking whether any standards are recommending this online testing and all. Actually, as a member of various technical committees in BIS, you should answer this question, is my request. In fact, if you are asking specifically for medical location, which is the subject of today, the online monitoring is required for several reasons. But when we talk about the verification for safety purpose, then most of the tests are off condition.
No,
So
no, no.
I hope,
I'm not mentioning online, but is it when anything something called 0-hour testing is there in that in the standard or not? That's it.
Sir,
Sir, I'll
as a member of the committee, probably you must be aware. You should explain to the participants whether it is there or not. I hope my answer is
But
not
what medical, leave it. Medical side, I'm not looking into it. But electrical side, definitely, I would like to recommend. Definitely, it is not there anywhere. And asset monitoring is only becoming very important recently, because many people are not monitoring a lot of equipment. But since the technology is evolving, and more opportunity to monitor many of the electrical assets, especially the substation asset. And so I would like to recommend in future any such approach, because
Sir,
otherwise
restrict our questions for medical, because today's anyway the subject is medical, and within the hospital, if we can restrict, would be great.
yeah, medical also it is very important there.
I speak now.
Thank you. So
Yeah.
anyone else, Mr.
Yeah.
Davis?
Very insightful presentation or training. Thank you, both of you. Now I have a question for the critical area, that is group 2 of a hospital. Now we are using IT system in that area for continuity of the supply. But how the automatic disconnection part, if Mr. Goba can explain a bit more on that, because automatic disconnection is also important there. So how it is being achieved?
In medical location, during first fault, you cannot disconnect the supply. Continuity of supply has to be ensured. Continuity of supply under first fault has to be ensured. So we are not talking about disconnection for that during this period. Of course, a double fault, the second fault could disconnect the supply.
No, I understand that. Yeah, I understood that. But only thing is it when the first fault happened, then what happens? Who takes care of that alarm?
You have a monitoring system. The monitoring system will tell you well in advance. Let's say you have 12 channels, 12 circuits used in an operation theater, or maybe 1 or 2 operation theaters. The device will tell you in advance that one of the line, the insulation is weak, and even if there is a fault, it tells you which line the insulation fault has happened, so that you can take care of it. If there is some activity going on, you can complete the activity, and after the activity you can repair the system.
Thank you. So it is done through isolation transformer, this IT?
Pardon?
Is it supply is provided through isolation transformer for group 2 areas?
Yes, medical IT system, yes.
Okay.
Yes.
Okay, thank you.
Thank you. We have some more people. HIC department, somebody has raised the hand. Also, Veena V. Devan, Mr. Tara Dhal, Mr. Manoj Kumar Upadhyay, Deepa Prabhu. So, if you have any question, please unmute yourself.
Yeah, good morning, and Tara Dhal here. We have it's audible.
Yes.
We have got trauma care units, and we have got mother and child care units, where we have got many ICUs together and even emergency ICUs together, many OTs. It's very difficult to go for the security level over whatever it has been discussed today in those ICUs and OTs. And most of the electrical connections are being taken above the ceiling, fall ceiling. And recently also, about 3-4 years before, there was a very severe incident in Bhubaneswar that ICU patients, they died because of the fire within the ICUs. And the ventilators, the ICU patients who are in ventilators, they had died because of the smoke, not because of the fire. And when the smoke occurred, the people ran away. They didn't help it. So the patients died because of the smoke. So we are designing basically hospitals of that type where many ICUs and many critical care units and OTs are there in two different floors. How to combat that? How to avoid that? Because everything will take care as per the code, but when it occurs, nobody is there to solve. Nobody is there to support.
Can I
So
answer this?
that's the problem. Yes.
Thank you very much, Mr. Taradhar. Your question is very well appreciated, and it was a very good question. You see, the basic idea is any location. I'm sure all of you agree that it's a highly critical location, no question about it. Now, this highly critical location has to be designed, selected, and erected, plus maintained according to the highest possible safety levels. Now, if there is already an installation which is unsafe, the chance of ignition of fire, we are not talking about smoke or the situation after the fire. We are talking about before the fire, or how to avoid ignition, the sparking itself. If there is no ignition of fire, then the situation is totally safe. So we have to make the installation, we have to maintain the installation in such a way that just forget about ignition due to electricity from the entire area. That is how, in technical terms, we say thermal effect. So electricity, when you use it for normal purpose, should not create a temperature rise more than certain things. As a result, arcing, spark over, all these are avoided. Now, in an existing installation, which is already installed, the wires are running somewhere, actually nobody knows. The best method is to make a periodic verification as per the National Electrical Code, which tells you if there are any loose contacts, then you can identify all the loose contacts very well in advance if we go through the tests recommended. For example, if you do a fault impedance test with a high current meter, maybe 200 amps meter, and if there are loose contacts in your wiring, immediately you know that the places where the loose contacts are there will be arcing. So then such mistakes you find out and you rectify it. As a result, you can achieve certain amount of safety. But running the installation in an unsafe situation is risky, I would say. I hope the answer is clear.
Second one, I had this thing also that the horizontal evacuation and the vertical evacuation and the compartmentation, what Mr. Deshmukh told recently, that in horizontal evacuation in compartmented multi-storied hospitals. So that way, as per code, it is not feasible. As per code, they are saying that you should go for ramp, you should go for the refuge area after a certain height, not in every floor. So we have got, because of land shortage, we are going for multi-storied hospitals and we are putting the OT and the critical units at the top floor usually. So remaining other floors where we have got IPDs and other ISDUs say, So need to provide the refuse areas and to avoid dams.
Actually, I am not an expert, neither Mr. Adanu is an expert in fire handling, after the fire, how to evacuate, how to handle the fire situation. We are not the experts. And I think Mr. Deshmukh sir is also not there. Probably we will take up this question later on and we will try to answer. But please note that the whole idea of the program is how to avoid the ignition of fire, how to make the place safe so that we don't need to talk about so many incidents. I hope you appreciate this
Yeah.
point. Thank you very much. If anyone else have a question, Apav sir, you have unmuted yourself.
Yeah. Good afternoon, sir. It's a wonderful webinar by Mr. Gopalji, Deshmukhji, and Attanuji. Once again, thank you all, the NFE. So I'm coming to the only one point I would like to cover regarding the calibration as raised by Mr. Chilukuri, Dr. Chilukuri. So actually the facility, the NABH has prescribed some standards in which the protocol is there already under Facility Management System FMS 5. A medical equipment must be periodically calibrated. Also under FMS 4, for utility equipment, also, for example, relay, roof impedance, testers, etc., they should also be calibrated periodically. So coming to the periodical calibration, there is no such term of zero something like that Dr. told. What is available in the national and international standards, I would like to just a few words on it. Actually, it's a type evaluation report. For example, any calibration shall demonstrate unbroken chain of traceability to international standards. So any calibration, if you make it in Chennai or Mumbai or Geneva, it should be an international acceptable one, based on which only the ISO has evolved one standard, that is ISO bar IEC 17020 and ISO bar IEC 17025. They clearly provide the various protocol. Actually, the NABL, National Accreditation Board of Laboratory, is also coming under Quality Control of India. Some other department like NABCB and NABH, they cover the complete protocol, how to make a calibration laboratory accredited. It doesn't mean that you should own a calibrated laboratory. You can have your equipment tested at a calibrated laboratory. Then your equipment will be your equipment results will be traceable automatically back to the international standard. This is the protocol available. So it is in that protocol, NABL has already given out a very beautiful document under 141 and 142, 145. There are various documents they are given. These three documents will give you the thumb rule is you have to be cautious while using the equipment. Even if you find there is an error, you have to readily check it. A comparative test check is also there. If there is a deviation, then you have to go for calibration in the interim period also. If the calibration is periodicity is clearly provided in the NABL calibration certificate, but doing usage, you can have a parallel test with any other person who is having an NABL certification or your own additional equipment, which may be of less accurate, but you should be confident whether your equipment is wrong or right. Then you can go for calibration with the NABL laboratory. There's a basic protocol available for the calibration of equipment. It is a must, whether it is an utility equipment and or the medical equipment, because your IMD, for example, insulin monitoring device should not malfunction. It should be calibrated. So there are things clearly pointed out in NEC as well as the NABH documents. I request a participant to go through these specific standards of NABH, FMS, Facility Management System, which is outlined there. That's all from me. Mr. Gopa, thank you all.
Thank you
Yeah.
very much, sir. There were
Thank
some
you.
questions somebody asked regarding one of the answer which I made. There is a confusion. The confusion is please clarify on earthing of electrical equipment as it is contradictory, that is not required to get multiple or single earth electrode. Let me repeat my answer. For the purpose of electrical safety means you have a building where the voltage is less than 1000 volt DC or 1500 volt, 1000 volt AC or 1500 volt DC. That means the low voltage electrical installation in a building which includes your house or your industry or whatever for the purpose of electrical safety. That means for protecting people from electric shock and protecting your installation from arcing. An earth electrode may be required. It's not mandatory. May be required in the sense, first of all, to protect from shock and arcing, you must interconnect the entire, all metal objects or technically we call as simultaneously accessible metallic parts must be bonded together. That means you have to have a very good equipotential bonding inside your building, which is a mandatory requirement. An earth electrode in soil, if you have one, you connect to the equipotential bonding system. So, what is written is an installation may require an earth electrode in soil. May in the sense, it is not mandatory to have an earth electrode in your electrical installation up to 1000 volt AC, 1500 volt DC, which we are talking. I would like to make it again more clear. Not even one earth electrode is required for protecting your people from shock and protecting your electrical installation against arcing. Since not even one is required, we can just forget about multiple earth electrodes. So not even one is required for protecting protecting people from electric shock or from arcing up to 1000 volt AC, 1500 volt DC. If you have confusion, I request you please download IS 732, IS 3043. These are very good technical documents and you can read it completely. So a lot of informations are there. I hope my answer is clear. Thank you very much. Then somebody asked how come multiple things are there in hospitals. This is unfortunately not the correct method. We have to actually change. Thank you. Chatanu, you would like to take up any questions because there are so many questions further.
Yeah, last question. Yeah, we are going down. So there is I want to discuss Mubarak Khan is a question: periodic testing of biomedical medical equipment, periodic testing, how to ensure. So basically, to answer that question, that two questions like periodic testing of biomedical and medical electrical equipment, periodical testing of medical isolation panel and earthing system in OT. So first one I'll take, Gopa Kumar. So biomedical periodic testing is that one is that you have to have idea is that depending on your usage you can have your own periodic maintenance. As I said in one of the slide, you one needs to do their own risk assessment, okay, and based on that, once you do the risk assessment, some medical equipment can come once in 6 months, some can come once in fall under basically once in a year, at least bare minimum periodic test, apart from the anytime you are having the fault and other things, okay. So these are the bare minimum. So basically idea is that risk assessment, if you are not probably your time or is doesn't permit any your own risk assessment, you can write to us, we can help you in doing the risk assessment or the document which can have the risk assessment. And second question probably Gopakumar, if you can take the periodic testing of medical isolation panel and earthing system in OT.
Yeah, this has to be done. I think once in 36 months or so. It is there. One moment, let me read it. The periodicity is functional testing of insulation monitoring devices 12 months. Every 12 months we are supposed to make this particular testing. You can go to page number 476 of NEC, clause number 9.2, that is there. So,
There is two more questions
go
from
ahead.
Mr. Niranjan Kambate, Dr. Niranjan Kambate.
Yeah, will TNS system have three-phase, one neutral and one earth coming all the way from substation? Yes, Mr. Niranjan, exactly what you said is correct. We are supposed to use a TNS system for medical, normal location in the group 0, group 1 locations in the hospital. It means it's a 5-wire system. You have three-phase, you have one neutral, and you have one separate protective earthing conductor coming from the neutral of the substation. So 5 wires has to be distributed. The 5th wire, which we call as protective earthing conductor, all the class 1 body of metallic parts of class 1 equipment or protective terminal of class 1 equipment, and or the technical word exposed and extraneous conductive parts must be bonded to the 5th wire, which is called as the protective earth conductor. That is the correct way. Thanks for the question. So now this also means there is no separate earth electrode in soil is required. So with this, probably Lakshmi, over to you. There are several questions. If we start answering, it becomes an endless.
Yes, sir.
Yeah, it's already
Thank you, everyone.
close.
I would request Dr. Prabha, Senior Director of NFE, could give the vote of thanks.
Who should unmute? Ms. Prabha, you should unmute. Maybe Lakshmi, you can make the vote
Yes,
of
sir.
thanks and conclude.
Yes, sir. Thank you to all the speakers, participants, having time to attend this webinar. Hope to meet you soon in the next webinar. Thank you all. Have a great weekend.
Thank you.
Thank you. Thanks to all. Thanks.
Thank you.